What we're going to do today is we're going to graph quadratics, and we're going to look at some application problems. We're going to find the vertex, the zeros, which are also the x-intercepts, and the y-intercept of a quadratic function by hand and graph. And then we're going to find the vertex and the zeros using a graphing calculator. And then we're going to use our knowledge of quadratic functions to solve real-world problems. Okay, so let's kind of recap when we're graphing quadratics. So some of this is old, some of this is new. So we want to find the vertex. In order to find the vertex, x is equal to negative b over 2a. To find the y-coordinate, we have to plug x into the equation. To find the y-intercept, x is going to be equal to 0. So if it's the y-intercept, okay, it's where the graph is crossing the y-axis. So at that point, x is always going to be 0. To find the y-coordinate, we're going to look at c. Okay, the c term, that's your constant when it's in standard form. Okay, to find the x-intercepts, we look at the x-coordinates. And in order to find the x-coordinates, first we have to factor our quadratic that's in standard form. And then we have to set each factor equal to 0. And then solve. Okay, and then the y is going to be equal to 0. And wherever the graph crosses the x-axis, that's the y value is always going to be 0. Okay, so now we plot these points and we sketch. And remember, if a is greater than 0, so if a is positive, you have a smiley face, so you have a mid. If a is less than 0, it's negative. If you're negative, you have a frowny face, and that's called a maximum. Okay, so let's kind of put all this stuff together and graph some. Okay, so I'm going to graph the following. So first thing we want to do is we want to find the vertex. So we're going to do x equals negative b over 2a. So positive 16 over 2 times 1. I get 16 over 2, which is 8. To find the y, I plug it back in. So 8 squared minus 16 times 8 plus 64. Okay, if we solve this, we'll get that y equals 0. So now I have my vertex. My vertex is the point 8, 0. To find the x-intercepts, I want to factor. So if I want to factor this, I want to come up with two numbers that are going to multiply to 64 and add to negative 16. Okay, so we can use negative 8 and negative 8. So if I go to factor this, I have x minus 8 and x minus 8 equals 0. And I want to find my x-intercepts, so I'm going to set each of these to 0. So x minus 8 equals 0, x equals 8. X minus 8 equals 0, x equals 8. Okay, so they both are the same. So that means my x-intercept is going to be 8, 0. And if you notice, that's the same thing as my vertex. Okay, that's okay if that happens. It might not happen every single time. It probably won't happen every single time. But if it happens, that's fine. And then our y-intercept is going to be 0, c. So my y-intercept is 0, 64. Okay, so I have my vertex, which is 8, 0. So if I graph it, 8, 0. And then my x-intercept is 8, 0 also. And then my y-intercept is 0, 64, which is way up top. So, really bad, but off the screen. But that is our parabola. Now let's look at another one. Alright, so now this one, if we do negative b over 2a, if you notice, there's no b term. Okay, this is a, and this is c. Our c is our constant. There's no x term. So since there's no x term, our b is 0. So my x value is 0. If I plug 0 in, 0 squared minus 25 is going to give me negative 25. So my vertex is going to be 0, negative 25. If I want to factor this, it's difference of squares. Since I can take the square root of both of them, and there's a minus sign in the middle, I can factor this to be x plus 5 and x minus 5. Okay, so I set that equal to 0. If I solve x plus 5 equals 0, I get negative 5. If I solve x minus 5 equals 0, I get positive 5. So my x-intercepts are going to be negative 5, 0, and 5, 0. Okay, and then the y-intercept is 0, comma c. So our c term is negative 25. So my y-intercept is going to be 0, negative 25. And again, this matches our vertex. So in the last example, the x-intercept matched the vertex. In this case, the y-intercept matched the vertex. Okay, so that could happen. Again, it probably won't happen all the time, but there it is. So then if we wanted to graph it, I'm going to count by 5s on the bottom. 10, 15, 20, 25. So 0, negative 25. And I'm going to count by 5s on the side. So we have 5, 0, and negative 5, 0. And whoops. Okay, here's our graph. Okay, graph of our parabola. So now we're going to find the zeros using a calculator. Okay, so what we're going to do is we're going to go to y equals, and then we're going to type in our function. So our function this time is going to be a negative 2x squared plus 8x minus 7. Okay, once we have it graphed, or put into y equals, we're going to hit graph. Once it graphs, you're going to see that this is a parabola, and because our a value was a negative 2, this is going to open down. Takes a very long time, but here we go. Alright, so we want to find the zeros. So I want to find my x-intercepts. So right here is an x-intercept, and right here is an x-intercept. But it doesn't lie on one of these tick marks. So this is like 1, 2, 3, 4. So it's not a whole number. So in those cases, it's going to be hard to find your x-intercept. You're not going to be able to factor it. So what we need to do is use our calculator. So what we're going to do is we're going to hit the second button, and we're going to go to trace. We want to find the 0. So you're either going to hit number 2 and enter, or you're going to go down to 2 and hit enter. Either one. Okay, when you do this, it says left bound. Okay, so this is kind of like how we did the maximum and the minimums last time. We want to find the left bound of the 0. So right here, if we want to find this 0, I need this little blinky thing to go underneath it, because that's the left side. So I'm going to just use my arrows, and I'm going to move it just so it's a little bit closer. So about here is good, and I'm going to hit enter. And then it says right bound. So I want this blinky thing to be a little bit above the 0. Okay, so these x and y numbers, they don't matter. If your numbers are different than mine, it's fine. The final answers should be the same. So I'm going to put this guy about here. Okay, so he's a little bit above the 0. I'm going to hit enter. And then it says guess, and I'm going to hit enter again. So now it tells me my 0. So 1.29, comma 0. So that would be my 0 here. So let's find the other 0. So if I want to find this 0, see if I can write on here. So let's write this one down. 1.29, comma 0. So that's this guy. So now I want to find the other one. So I'm going to go through the same steps. I'm going to go to second, and I'm going to go to trace. Ignore the writing on the screen. We're going to go to 0, and we're going to hit enter. So now we want to find this 0. So my left bound is going to actually be above it. So I want to move the blinky thing over. So it's slightly above the next 0. And then once he's in a good spot, okay, that's good. Oh. Go back. Okay, so once it's a little bit above, you're going to hit enter. And now it says write bound, so we're going to go a little bit below the 0. So we're going to go to the right. Okay, and we're going to hit enter. And then it's going to say guess, and we're going to hit enter again. So now it's giving us the other 0. So now this 0 is 2.7, comma, 2.71, comma 0. So now we found both of our zeros just by using the calculator. So now we're going to look at an application problem. So we have this frog jump competition, and the graph shows a function modeling the height of one frog's jump, where x is the distance in feet from the jump start. So we want to know how far did the frog jump. So the frog is jumping in a parabola, as you can see up here. Okay, so here's our parabola. We want to know how far he jumped. So we want to know the distance that he jumped. So if he's starting out here, we know that that's the point 0, 0. That's the origin. So if I find the other 0 on the graph, that's going to tell me the distance that he went. Part B says how high did the frog jump? So that's the vertex. We want to know how high he jumped. So when we have our vertex, x and y, we want to know how high he jumped. So the y is actually going to be our height. And the x is just the horizontal distance he's jumping, but the actual vertical height is going to be the y. So since this equation is not nice, we can plug it into the calculator, or we can do it by hand. Okay, either one, because you can factor this. You can take out the x, and then you can solve it. Let's use the calculator for this. So we're going to put in the frog's formula. So he is negative 0.029 x squared plus 0.59 x. So we're going to graph it. So if we look at this, we're going to focus on this part of the graph. Okay, so what we need to do is we need to just expand our window a little bit. So what I'm going to do is I'm going to click on window, and I'm going to change my x maximum to be 25. And I'm going to hit graph again. What this is doing is it's just moving my graph over slightly because it's giving me some more x values. So now when I look at this, I can see where it's crossing. So it's crossing right here, which is where he's starting from, 0, 0. If I want to find this one, I have to use the 0 function in the calculator. So I'm going to do second trace. I'm going to go to 0. And I want to find the one on the right side. So we have our blinky guy above. So we're going to hit enter. And then we're going to move him so he's below that 0. And then we'll hit enter again. Okay, and then it says guess. So you could have stopped him closer. Mine was just doing its own thing. And then we're going to hit enter again. So it tells us the 0 is 20.34. So that means the distance the frog jumped was 20.34 feet. So how far did he jump? 20.34 feet. How high did he jump? Well, now we have to find the vertex. So we're going to go second trace. And we're going to find the maximum. Since this opens down, it's going to have a maximum. So we want to find the maximum. Okay, so we're going to go to the left side of the vertex point, which is about here. So we're going to go to the left, and we're going to hit enter. And now it says right bound. So we're going to move our little blinky guy over to the right.